Hey, on the On.NET show, we're going to be looking at tracing .NET applications in production. Come check it out. Hey, welcome to another episode of the On.NET show. Today we'll be talking about tracing .NET applications with Sourabh. Sourabh, thanks for coming on the show, and how about you introduce yourself before we get into the topic?
Absolutely. My pleasure. And thanks for having me, Rich. So I'm Sourabh Shirhatti. I'm a coworker of Rich. I work on the .NET PM team, and my current area of interest is diagnostics and observability. So how do you ascertain what's going on in your application's runtime? How do you get more information, and how do you go ahead and solve it?
How do you normally end up caring about this? Is it, do some developers use this during their development workflow, or is it only when your application is crashing in production? What would be the cases where you would care about observability, as you say?
I mean, there's an entire gamut, right? There's
Okay.
from your development workflow, you have some tools like your debugger as well as your profiler, right? You do performance profiling at the time of development. You also have what we call like production diagnostics. People monitor metrics in production. You look at, metrics like allow you to get early visibility into something if something's wrong, and then you usually follow that up with deeper diagnostics, right? If metrics are telling you something and you go look for logs, and the logs also indicate a problem, maybe you collect a process dump, maybe you collect a trace. So this really spans the entire gamut, and both like from low observability overhead all the way to extremely high observability overhead, and the gamut of my local development flow all the way to in production to airtight boxes that I can't access.
Right. So what were you wanting to focus on today?
So today I want to talk about tracing.
Okay. So yeah, take us through that. Where would you start with tracing? Is that something you do within your application where you're writing it so that it's ready to be traced when it's in production? Or are there some aspects of tracing that you kind of get for free out of the box and you don't have to do that in your app at all?
Uh, so for the most part, tracing has a high observability overhead compared to something like metrics. So it's usually a conscious decision that, hey, I want to collect a CPU trace. So I can give you like two tangible examples to that end. One would be I'm in my local developer workflow, and I just eyeball some code, and I'm like, hey, this might be slow. I want to optimize it. I want to improve the performance here. I go collect a trace. Another example could be something like the application insights profiler that we actually offer as part of Azure, where you have like an endpoint in your application in production which is slow, and then you want to profile that application when you have whatever user input occur, and then capture those traces for like postmortem analysis.
Sure, that all makes sense to me. I think really what I was trying to ask is, when you trace, how much do you rely on inbox data? I don't even quite know what the word is. Tracing items that our team has provided versus tracing data that you've added yourself. That's custom to your application.
So it's a mix of both. I'll say the most common use case is CPU tracing, and we actually in the .NET runtime ship an event source provider that is a CPU sampler. So I think it's a one megahertz, right? That's 1,000 times a second. It will stop all your threads and do a stack walk, capture all your CPU samples, and that's the most common use case. There are obviously other event source providers that we have in the runtime, things that you might be interested in, something like maybe Kestrel if you're doing a web server, or HTTP client if you're doing a client, as well as we have the same tools that are available to us are available to customers. So you can write your own custom event source.
Right. So I think the real thing I was trying to get at is if you have apps in production already, that you never thought about tracing before, this video and everything you're going to talk about is still relevant. Like
Absolutely.
you can get value out of tracing, even though your app wasn't kind of quote unquote tracing aware, because
That's right.
the runtime itself is tracing aware, and there's a ton of value in that. Okay, let's turn to something a bit more concrete. Do you have something you want to show us today?
Yeah. Let me go ahead and pull up my screen, and let me know when folks can see my screen.
I can see it.
Oh, that is awesome. Okay. So I have a simple application here. So, and just to add some fun to it, I am currently running my application inside of Linux. So I have a Visual Studio Code instance open, and there is something called the dev container file. So you can tell VS Code, hey, build and boot this Docker file, and then give me a shell inside this so I can run my code there. I mean, part of this is twofold. I want to show you a flow where I am developing on Linux, tracing my application on Linux, and then observing and analyzing that on Windows.
That's a pretty awesome flow.
So I have my application published already. So it's just, I've gone ahead and .NET published it. And then now to run this application, I need to provide it an image. So while this app is waiting for my output, and while it continues to wait, I can show you. Oops, I'm trying to. Maybe that isn't the best way to show a picture. It's probably easier if I do this. Okay, there you go. So I have a simple image. This is the .NET bot that we're all familiar with, right? And we're going to be performing a couple of image transformations on it. So to keep this simple, I'm just giving a little background on the application because it will help before we just start tracing something which we have no idea about. This application will convert my PNG file into a PPM file. So PPM file is a very simple image file. I'll see if I have a copy here. If not, I can show you one when we're done actually running this application. So first thing I'm going to go ahead and do is I'm going to run this application, and I'm going to run my transform PPM slow. And I have aptly named it slow, just so for this purpose of this demo, I don't forget which one is the slow one that I intend to trace. So it's taking a couple of seconds to run.
So does is PPM a text-based format instead of a binary one? Is that the distinction between the two?
Yeah. Well, there are more stuff. So I'm not an expert on image formats, but image formats have like codecs and compression and stuff like that. We're taking the easy format. PPM is a simple textual-based representation. There's a preamble, then it has metadata like what the size of the image is, and it's literally after that it's pixel by pixel. It's the RBG and alpha values for every pixel.
Okay, makes sense.
So now that ran.
Okay, so that took 21 seconds.
Yeah, and so it produced this file, which I'm going to try and. Okay, so you see this? It's just format, metadata is the size, and this is just literally every pixel. You're only seeing a bunch of 255s because we're seeing the exterior of the image right now. But yeah, so this is what the format looks like. It's just simple, pixel after pixel in a textual format, right? So this took 21 seconds, right? And this is obviously taking a little longer than we'd like it to take. So what I'm going to do right now is I'm going to showcase the diagnostic tools that we make available with .NET that you can use to profile your application and see what's going wrong, right? So now what I'm going to do is I actually have another terminal window open here. I'm going to hop over here, and I have already installed the dotnet-trace tool. For folks who don't have it already installed, you can do .NET tool install -g .NET-trace, right? So this ships on NuGet as the SDK tool. So as long as you have the SDK, you can install it. -g just specifies it's a global tool. This would fail for me because I already have it, but let me just go ahead and run .NET-trace. Okay, so I have like a 3.1 something version of this tool. Once I have the tool installed, let's go ahead and just run dotnet-trace help just to show folks what it is. So we have a couple of options. So the first thing we probably want to do is see the list of available processes. So you see this one, page 3605 with the name ImageMage. That's the application I'm running in my other window. That's the one that we want to profile. So I'm going to go ahead and do dotnet-trace. I'm going to hit collect. And just before I run it once, I'm actually going to run the help on this to answer a question that you asked earlier. So what I'm doing is I am not specifying any providers, right? So it's defaulting to the default provider is just the event source provider that enables the sample CPU profiler and nothing else, right? If you wanted to do more custom things, you can actually, provide the list of providers as well as their flags, levels, keywords, and any custom args that you pass to it. So with all that established, let me go back and get my pages. It's 3605. So I'm going to do .NET trace collect. Oops, sorry. And just before I hit enter here, I want to make sure I have everything ready here. So I'm going to say, I'm just going to have this ready typed out so I can swap back and hit run. So I'm going to hit this, and so it started collecting a trace, and let me start my transform now, right? So now there is this observability overhead. So remember, it took about 21 seconds last time. It is fair to assume that it will take a little longer.
Right, because of the observability overhead. So one thing to mention that I was going to say earlier, but now's the perfect time since we're waiting, is when you typed .NET trace -- version, it was 3.1 dash something, and then a plus, and then some crazy piece of text after that. So some people might not know what that crazy piece of text is. So I assume that that's the commit from the .NET
diagnostics repo.
Yeah, .NET diagnostics repo at which that tool was built.
That is correct.
Yeah, so if you want to go back and look at the exact source code that was used, for kicks or to actually like validate some bug or whatever, then you can do that, which I think is really, really good. Okay, but we're done now.
So we're done now. So we have a trace. So if so you can see I have this file called trace.nettrace file generated. So this is the default container format for any trace file that you get. But there are a couple of tools that can read this format out of the box. The main ones being Visual Studio and Purview. But before I open this in Visual Studio, I also want to show that you can actually analyze this on, say, a non-Windows environment as well. So even though my machine is Windows, I'm going to convert it to format and open it in a tool which is cross-platform. So I'm actually going to go .NET trace convert. I forget the argument, so let me look that up real quick. Let's see. Format, speed, scope, and it was trace.net trace. Okay, so this is converting it to this format. So what I'm going to go ahead and do is we pull over a browser window. So we have, so there's this application called speedscore.app. It's just a hosted application. The other thing is it is actually packaged as a PWA. So you can also go ahead and click, if you're running Chrome or Edge, you can go ahead and actually install this as a native app. I've actually gone ahead and done that because it's convenient to have for cases when when I don't have access to the internet. So it actually just shows up like this. If you've used any PWA, it's basically a browser shell and the application in it, which is a little neat. And now I can go ahead here, and I'm actually going to open this trace that we just collected, right? So now this is the trace that we just collected. Right now, this is still a bunch of, I'll say, like it's still difficult to ascertain what's going on. So let's take a look at it together, Rich, and then we'll figure out what actually like took the majority of the execution time in the application that we just ran. So this is the time order view, right? So this is effectively, you're seeing every stack as it was snapshotted superimposed here, right? So these were obviously long running tasks versus you see these tiny icicles, they ran for a much shorter duration of time. So we know a little bit about what went on in the app, right? So if I zoom in, if you hover over this, you see this right now says text.readline. So this is prior to our area of interest in this observation, right? We only care about what happened to the application after because this is when it was just waiting. So what I'm going to do is I'm going to look at this corresponding section and, oops, I'm really not good with the Windows mouse. How? Sorry, guys. I'm trying to select this.
How about you tell us what you're trying to do so that people grasp? You're saying you're trying to collapse this in some way, right?
No, I'm not actually trying to collapse it. I'm trying to narrow my area of observation to just when my transform ran, right? So you see here, I'm waiting for readline. Readline wasn't something I care about in analyzing why my application ran slowly. That was just a user taking their time on the command.
Yeah, that's not indicative of a performance problem.
Right. So I'm trying to narrow it down to everything from this point forth. And for whatever reason, I'm stuck with the pinch tool. Let's do this. Oh, there you go. Okay. So this goes on for a while, but I think, oh shoot, okay. I figured out how to do it with the mouse. Okay. So now I've removed the read line and I've made the area of observation only something that we care about, right? And now this is still not useful to read. So instead of the time order format, now we're going to look at the left heavy format. So what the left heavy format does is it says, hey, a lot of these stacks, like you're performing if you're performing operations over and over again, they probably have some common ancestry when you look at the stack. So let's combine all common stack frames so that we can see what actually took the most execution time. And when I do that, this actually becomes a lot easier to read. Because let me just hover over something like this, right? String.concat. Now it shows up as one large observation, but earlier it was actually split across multiple different icicles. And when I look at this, that's something that should scream out to you. Why is string.concat taking so long? Right? So armed with that knowledge, it might actually be useful to go back to the offending code, and maybe you and I can collectively spot why it took so long. So I'm going to go back in here. This is my program. Oops. Let's hide this. All right, and let's go to the ppm slow. Okay, convert to ppm slow. And when we look at this, is there something that screams out to you, Rich?
Yes. So basically, it's this plus equals thing that we keep on doing. So, and it's the worst in the for loop. That's right. It's good that you're using an interpolated string, but that doesn't really help you much because you're going to have to plus equal that string for as many times as the width. So it seems like you should be using string builder here.
Absolutely. You said width, but it's actually worse. It was a nested loop. I don't know if you missed that.
Oh, sorry. It's height and width. Yes, I missed that. But
yeah. So we're actually allocating a lot of strings, and you see that, and you see the profile. Totally. You're like, oh, okay. Yeah. So I'm not gonna live code for the purpose of this demo, but I'm gonna just scroll up a little bit.
Yeah, although it'd be pretty easy to fix. But yeah.
And this is what the fixed version of the code looks like. Just let's use a string builder so we don't allocate a lot, right? When we look at this, you're like, aha, this has to be an improvement. So if I go back over, sorry, I don't have to actually go over. It was in this window. And let me run this again, but use the right transform this time. So if I run the ppm transform and not the ppm slow, and now that we've found the issue and replaced it with the string builder, and when I run the corrected transform, you can see that it took a lot less time, like well under a second. So this is an example of where we were able to use SpeedScope to perform an easy initial investigation, not change my workflow and get some information and insights. And while SpeedScope is good for some naive tasks, Visual Studio is actually performance tool that natively understands the net-trace format. So while SpeedScope only allowed you to visualize CPU stacks, and it only did so well for a single thread, Visual Studio has a couple of reasons why it might make a more compelling consumption experience. It'll stitch together like common stack frames from across threads. So it's actually way easier to diagnose issues when they span multiple threads. It also natively understands the net trace format. So you can see your like CPU samples superimposed with other events. And we're adding support for things like an allocation profiler in Visual Studio, adding support for visualizing just generic events. So all that stuff is coming, and that might be a compelling reason why you might want to take your net trace file and open in Visual Studio. So what I've done in this instance is I've already gone ahead and opened that file in Visual Studio just to show you what that consumption experience looks like. So if I go to Visual Studio, it's similar view starting out with. Remember, we have the time view over here, and I've actually narrowed my interest of observation to after I know the system read line has progressed. And like right here, without like Visual Studio has a couple of smarts, and you can see the hot path is just detected for you right here. So as soon as I open the file, I'm like, it's string.concat happening inside of convert to ppm slow.
Okay, that looked really good. So, so it sounds like Visual Studio has that functionality as is. Like you don't have to install anything in order for it to be able to read those formats. That's right, isn't it?
That's correct. Yes.
Yeah, yeah. So basically, you just need to be able to download the dotnet-trace tool and then trace processes on your machine, and you're good to go.
Right. So the runtime already has required things to egress that information. You just need to get the command line tool .NET-Trace to actually connect to the runtime and request for that information.
Right, but that's just a function of typing the .NET-Trace command for that process and then making sure that you have a way of collecting that trace file off of that machine to wherever you want to read that trace file. Like for example, in that dev container that you were using, one thing I was curious about is, like, did you have a volume mounted where you were able to, copy or somehow grab that file out of the container? How did that work?
Yeah, so that's actually one of the nice things about working with dev containers in VS Code is that your local file system is mounted as a volume mount inside the container.
Right, so it's super natural then.
Yeah, so I just opened it in File Explorer and my generated trace file was right there.
Yeah, yeah. So obviously, Visual Studio Code Remote kind of makes it so that you almost don't even have to think about the question I just asked. Some other environments, you might have to do a little bit more configuration so that you can get access to that file.
Yeah.
Okay, so maybe the thing to do just before we close is, could you maybe bring up the .NET-Trace NuGet package in your browser so that people know that this is the one to install?
Right.
And then I think that's about it.
Let me just show a quick couple of things. So this is the .NET Diagnostics repo that you mentioned earlier. This is where all the tools are built out of. If you're interested in the implementation, it's all here. And I'm going to go ahead to NuGet.org and just show you .NET-Trace. Oops. Let me do this.
Yeah, I was thinking.
All right.
Yeah.
That's the name of the package. And you should see that like NuGet, the website actually knows it's a tool. So it prompts you with the install experience rather than the package reference experience.
Awesome. Right, and you can see it's updated somewhat regularly. It was updated 20 days ago. So your team is obviously focused on making this better. Yeah, thanks for being on the show again. And hopefully people can use this as like another tool in their tool belt for making great .NET applications that perform super well.
Looking forward to that.
Yeah, me too. Okay, take care. This has been another episode of the On.NET Show talking about performance tracing with Sourabh. Thanks for watching.